Hello everyone, this is Ma'am Amano, and this lecture video is all about the sample problems for acceleration. Okay, so we have defined acceleration as a vector representing how fast and in what direction an object's velocity is changing. Acceleration is the time rate of change of velocity, wherein the formula for that is that average acceleration denoted by an a bar is equivalent to the delta of the velocity, which is Vf, final velocity, minus the initial velocity, and then the elapsed time or change in time, which is the final time, TF, minus the TI, if you will expound this formula. All right. So for sample problem number 1, I have here the following given values. For final velocity, I have 13 meters per second, initial velocity of 2 meters per second, time is 24 seconds, and then we are looking for acceleration in terms of meters per second squared. The unit for acceleration is that the time here is raised in the second degree. Okay, it might be let us say meters per second squared, or kilometers per hour squared, or kilometers per minute squared, or miles per hour squared, so long as the time at the denominator of the unit is raised in the second degree, therefore that is an acceleration. So to solve this problem, we have here the average acceleration is equivalent to the delta of the velocity or change in velocity over the change in time. If you will expound that, that is final velocity minus initial velocity over the final time minus the initial time, or final velocity minus initial velocity over the total time. So for average acceleration, that is the final velocity of 13 meters per second minus the initial velocity of 2 meters per second, and then over 24 seconds as our time. 13 meters per second minus 2 meters per second is 11 meters per second, and then 11 divided by 24, that is 0.458, and then meters per second, or meters per second squared. That is the unit for average acceleration or acceleration. Then sample problem number 2, if a car could accelerate at the rate of 50 meters per second squared, how long would it take for it to reach a speed of 25 meters per second from rest? So, to find that, we are looking here how long, so we are pertaining to time. We are looking for the time. Okay, so we have to manipulate the formula, but first let us stipulate the given values. We have the acceleration of 50 meters per second squared. The initial velocity is 0 because from rest, okay, from rest here, so that means it is 0. And then the final velocity is 25 meters per second. So to find the formula for time, you have to derive the formula in triangular terms. So that is acceleration is equivalent to the delta of the velocity over the time. So that will be time is equivalent to the change in velocity over the acceleration, when which the time is equivalent to the final velocity of 25 meters per second, and then minus the initial velocity of 0 over the acceleration of 50 meters per second squared. So from here, we can already cancel the meters unit, and then rule of sign, since they are both in the denominator, here 2 minus 1, that is, you will be left out with second only. That is 2 minus 1 on the second unit, so you will have seconds in first degree only. Then 25 divided by 50, that is 0.5 seconds. Therefore, the answer is 0.5 seconds, meaning to say it will take about 0.5 seconds for it to reach a speed of 25 meters per second from rest. So the answer is this one. And then for sample problem number 3, I have here the final velocity of 21 meters per second, initial velocity of 0, time is 43 seconds, and then acceleration that must be in meters per second squared. Okay, so substitution formula is average acceleration is equivalent to the change in velocity over the change in time, which is, if you will expound, that will be final velocity of 21 meters per second here minus the initial velocity of 0 meters per second over the time of 43 seconds, and then 21 meters per second minus 0 meters per second, that will be 21 meters per second, and then over 43 seconds. Then you will have here 21 divided by 43, that will be 0.488 meters per second, or meters per second squared. Okay, then sample problem number 4, I have here a driver traveling at 140 kilometers per hour along a highway sees a dog in a distance. He applies the brakes and the car slows down at a uniform rate of 15 kilometers per hour squared. So how long does it take for the car to reach the speed limit of 100 kilometers per hour, and how far has the car traveled during this time? Let us answer letter A first, but let us stipulate the given values. We have here the initial velocity of 140 kilometers per hour here, and then the final velocity of 100 kilometers per hour based on the problem here on A. How long does it take for the car to reach the speed limit of 100 kilometers per hour? So therefore, this will be your final velocity. And then our acceleration is negative 15 kilometers per hour. Although you have here the 15 kilometers per hour, but our squared rather. But why is it a negative acceleration? This one is deceleration or negative acceleration. Why? Because he applied the brakes. Meaning to say, he tried to stop the car to lessen the acceleration. So meaning to say, this one is an example of deceleration. Deceleration. Okay. What is that? The slowdown of the acceleration. So that's why it is negative. Because he applied the brakes. Okay? So let us find the time. How long? Again, we are looking for the time. So, substitution, the formula is this one from the earlier formula. So, you have here your time is equivalent to the final velocity of 100 kilometers per hour. And then, minus 140 kilometers for your initial velocity over the acceleration of negative 15 kilometers per hour squared. So, the next thing that we need to do is 100 kilometers per hour minus 140 kilometers per hour. Then, that will be 40, negative 40 kilometers per hour, law of sine. And then over negative 15 kilometers per hour squared. So you have to cancel the km unit, numerator here, but this one is in the numerator and the other one is at the denominator, but it's placed in the numerator part. So law of sine for this one, hour squared and hour, so that you will be left out with the hour unit in first degree. And then negative 40 divided by negative 15, that is 2.67 hours. This is your answer here. Therefore, the answer is it took about 2.67 hours for the car to reach the speed limit of 100 kilometers per hour. Now, let us answer letter B. How far has the car traveled during this time in reference to letter A, of course? So, the formula is D is equals to the final velocity multiplied to the time plus the acceleration multiplied to the time squared over the 2. So, substitution, our final velocity is 100 kilometers per hour multiplied to the time, which is 2.67 hours. And then plus, the acceleration is negative 15 kilometers per hour. And then 2.67 hours squared for the time. And then over 2. So, 100 km multiplied to 2.67, you will be cancelling the hour unit here. And then you will be left out with 267 kilometers plus negative 15 kilometers per hour squared, and then 2.67 hours squared, that is 7.13 hours squared. So cancel the hour squared here, cancel as well. 15 times 7.13 over 2, that will be negative 53.48 kilometers, and then 267 kilometers minus 53.48 kilometers, that will be 213.52 kilometers. This is your answer. So for your practice exercise, you just have to answer this on your own. No need to submit it to me. Okay, hindi na kailangan i-submit ha. Sige. We will be answering this during our lecture consultation as well. So, that is all for this lecture.